This is an automotive brake. So only thing missing here is a lever here. So once you apply force with your foot, it actually multiplied by the brake lever. There is a problem solved in the open educator. You can see typical brake lever ratio. So it multiplies force a little bit, and then it goes to this thing called brake booster. So the way this is very simple. So one side you have the atmospheric pressure, the other side you have the engine vacuum. So what it does basically, so one side engine vacuum, less pressure, another side is the atmospheric pressure. So that multiplies your force that you apply in here even more. Then it goes to a very narrow master cylinder inside diameter, very small. So that force divided by smaller area, that increases the pressure developed by the master cylinder. Then it goes into a brake line, and in the end it goes to the caliper cylinder, which is pretty large. I would say this is about 3-inch diameter. So so the whatever pressure coming here, based on the Pascal law, same pressure will be transferred. You can ignore the elevation, couple of feet. This actually sitting low, so actually there you will have even more pressure because of the elevation height. So but in this case you're talking about 1,000, whereas the fluid weight, brake fluid, is not really for 2 inches. It's less than a 1 psi maybe, or even less than that. So it can be ignorable, the difference, elevation difference. So based on the Pascal law, whatever pressure is developed by the master cylinder, you can assume that's going to go into the brake cylinder, which is pretty large. So then to calculate the force, you multiply the pressure times the large area. So that will multiply the force one more time. So that's gonna actually, you can see that's the brake pedal in the both side. So basically that cylinder will expand as you press the foot pedal, brake pedal. So the cylinder will push the both side. So it will do like this. So that's how. But here what you're trying to explain is how the entire fluid power is used to stop the vehicles. Even the electric cars requires a manual like this mechanical brake system because of the safety purpose, because it can develop a huge amount of force with not spending a ton of effort. I have another cutout of the brake cylinder. As you can see, this is the line where the pressurized fluid comes, and this one actually has 2 cylinders. So one right here, the other side. So here is, you can see it has 2 cylinders like this. On the other hand, most cars have just 1 cylinder like this, but this one, so basically total area here actually doubles because you have the same pressure here, the 2 cylinder, but a larger cylinder actually has more areas than compared to just a 2 split cylinder, but that's a different thing. So here basically you see the cutout, and then the brake pads are pressed when this cylinder pushed out.